Cool. So this is Wesley and Clark. This is our group video for lesson 6 in genetics. We'll just start off with number 1 on those group problems. Number 1A, the first answer, it asks what's the frequency of the little d allele in the population. So it was pretty much the square root of 150,000, or of 1 over 150,000. And we got that to be 0.0025. 26. And so we rounded that to 4 decimal places. This is what our answers for number 1 look like. For B, it's the reverse of that, or the opposite of that. So it's 1 minus 0.0026, and we got 0.9974. For C, what is the frequency of the DD genotype? So DD genotype would be essentially the answer for B squared, and we got 0.9948. D is what is the frequency of the big D, little d, so the heterozygous genotype. And so that's the 2pq there on the bottom, you see. So 2 times the p and the q value, and we got 0.0052.
And then question 2 is our fill in the blanks. So the term in the Hardy-Weinberg equation that represents the frequency of the IB allele is Q, and the term that represents the frequency of the IA-IB genotype is 2pq. In B, that one individual is the Q squared. In C, we got the 399 or 3,999 of the others. They are the P squared and the 2pq. In D, it's the R allele, or the R is the term that will show the frequency of the dusky plumage allele. On E, once the terms in the Hardy-Weinberg that will represent the genotype of a duck with restricted plumage, that is can be the P squared, P squared, the 2pq, or the 2pr. On F, the human disease sickle cell anemia is the result of an SNP. On G, monomorphism is a term that describes a trait that produces a single phenotype in 99% or more of the population. On H, DEEM is another word for a local population. And on I, the MHC genes in humans are highly polymorphic.
Sorry, number 3 asks you what the frequency of a non-disease allele, so essentially the square root of 5,999 over 6,000. There's our answers for our work for number 3. And you get 0.9999. 1 minus that, of course, is 0.3 zeros and a 1. Which is what B is the frequency of the syndrome allele. C, what is the frequency of the heterozygous individuals? So the heterozygous individuals is the 2pq, and that's 2 times p and times q. We got 0.002, and that made sense because if there's one dominant person out of 6,000, it's most likely that they might be heterozygous, and that made sense where there was only 0.001 frequency with the dominant allele, but with the heterozygous occurrence, it was 0.002. So we know that one person that had it had to be heterozygous. For D, it's 5 million times that answer you got for C, and we got 1,000.
And then for question 4, we're talking about ponderosa pine trees. Let's see. 9 is reserved room. The allele frequencies for the R squared, or the R2 and R3 alleles. Let's see. That's our work, right? Whoa. Question 4. Nice glare. Oh, rainbow. So, for A on that one, the R2, we found that it was 0.8429, and then on the R3, you just subtract that other answer from 1, and you get 0.1571. On B, we then did the chi-squared thingy, and our, what do they call that? Our
chi-squared value.
Our chi-squared value is 9.2876. And so we compared that with the chart. And so for C, we decided to reject the null because the R3 allele didn't show up as much as it would need to be able to be in Hardy-Weinberg equilibrium.
Number 5, A, what is the frequency of the CCH, or the CBC, or the CC genotypes? Pretty much here's our work for it. So that would be the P squared, the 2RS, and the S squared values. So P is going to be the CCH, Q is going to be the CD, R is going to be the CB, and S is going to be the C. We got those values. B, among a population of 2,000 dogs, how many would you expect to have the pale gray phenotype yet be heterozygous? So that's our answer. One of our answers for A times 2,000, and we got 150 dogs. For C, it was pretty much the same thing, but you just do a population of 5,000 dogs, and you add in, it's for the CD and the CB, and then the CD and the C. And we got 920 dogs for that. For D, it is pretty much the sum rule plus what we were doing in this lesson. So you do, the first part is for the CH and the CB genotype. You find out that, and we got 0.185 to be that answer. And then for the CC genotypes, of course, we got that before, it was 0.0225. Each of those separately multiplied by 15,000, and then add those two answers together. We got 3,112 dogs. So those are our work for the lesson 6 group problems.